The Stiglitz report of the High-Level Commission on Carbon Prices takes a different approach to carbon pricing. Instead of looking for some optimal carbon tax, the authors ask what carbon prices would be consistent with the Paris Agreement. The report also gives a description of additional considerations such as other market failures like access to credit that can interact with carbon pricing. In my opinion, the consideration of carbon pricing and inequality is most interesting about the report. It may be good to note that the report does mention the possibility of complementary policies like command and control type of performance regulations that simply force or outlaw certain behaviors, but its focus is on carbon pricing. Policies that can introduce a price mechanism are either with a cap and trade or adjusting prices directly through taxation. A last category of policies are soft paternalism measures that do not change incentives. The panel gives the following reasons as its focus on carbon pricing. Carbon pricing can apply to all greenhouse gases. Carbon prices encourage producers to decrease the carbon intensity of the energy sector and manufactured products, and consumers to choose less carbon-intensive goods. By creating opportunities to increase profitability or save money through the reduction of greenhouse gas emissions, carbon pricing also promotes innovation and incentivizes the generation of new ideas and solutions. The hope is that carbon pricing will motivate the adoption of renewable technologies through making fossil fuel combustion uncompetitive. Similarly, a tax on plastics could stimulate the development and implementation of biodegradable alternatives. The report shows that while the share of emissions under some carbon pricing scheme is increasing, it also describes that 85% of global emissions are not priced today, and about 3/4 of the emissions that are covered by a carbon price are priced below $10 per ton of carbon dioxide equivalent. Worse yet, quoting page 12, according to the International Energy Agency, total fossil fuel subsidies in 40 mostly developing countries reached $548 billion in 2013, or 5% of GDP, and 25 to 30% of government revenues. The report clearly calls to end such subsidies on carbon and remains sensitive to distributional consequences as well. If done well, Stiglitz and Stern and the High-Level Commission argue that carbon prices can actually help to address income inequalities that will otherwise only be worsened by climate change. This map is taken from the World Bank Group and gives an overview where we can find carbon pricing initiatives today, where blue areas only had a carbon pricing scheme under consideration. In the first lecture, we had heard arguments in favor of a uniform carbon tax, since for the effects, it does not matter where carbon is emitted, and there are also many high emitters in developing countries. What makes this report interesting is that it argues how global climate policy with different prices could still be preferred. On page 18, the report reads, there are two interlinked reasons why lower income countries may choose lower carbon prices than high income countries. One, low income countries tend to have less ambitious objectives for emission reductions. And two, low income countries tend to require a lower carbon price to achieve a given level of emission reductions. The authors elaborate, when and where trade-offs between development and emission reductions exist, the imperative of development and poverty reduction may justify slower and more moderate emission reductions over the short term. A similar amount of emission reductions in a low-income country may have a higher economic and welfare cost than in a higher income country. Even if low-income and higher income countries aim for similar emission reductions in relative terms, such reductions may be achieved with lower carbon prices in low-income countries. This is in part linked to the availability of cheaper emission reduction options and the higher price elasticity of emissions in low-income countries. A given carbon price translated to local currency based on market exchange rates will also be equivalent to a higher local price in poorer countries, since the purchasing power parity exchange rates are usually higher than the market exchange rates. The Commission thus gave a Paris consistent carbon price corridor rather than suggesting a single carbon price. The Commission concluded such a price corridor between 40 and 80 US dollars per ton of carbon dioxide equivalent would be consistent with the Paris Agreement. On page 50, we can read that their estimate is based on evidence from industry, policy experience, and relevant literature, but it does not give a tremendous amount of detail how these are combined into the final estimate. The authors' their estimate is close to other recent estimates by the International Energy Agency, according to whom a carbon price between $90 and $120 per ton would lead to sufficient switching from fossil fuels to renewable energy to give a 66% chance of keeping warming below 2 degrees Celsius. The report also mentions how marginal abatement curves can be informative to get some idea about the cost and challenges to switch. Note that marginal abatement curves are often depicted with emission reductions on the x-axis. Here we see an estimate for such a marginal abatement curve, borrowed from Stern 2008, who in turn has it from a McKinsey report. The y-axis shows the cost per ton of carbon reduced, and the x-axis the number of emissions that can potentially be saved with the measure. One issue that is striking is that the marginal cost of the most left emissions saving measures listed are negative. That is, the introduction of insulation improvements is both emission reducing and saving money over its expected lifetime. Together, these measures that save both emissions and money are known as the energy efficiency gap. This energy efficiency gap puzzle has a number of possible explanations. For example, there can possibly be other market imperfections on the credit market, or there can be imperfect information about some of these measures, and the introduction of several of these measures are plagued by some form of principal agent problem. The typical example here is that renters and homeowners only see part of the benefits from their investment. Would the renter pay for insulation, the homeowner will benefit from the increased property value, while the renter enjoys a lower utilities bill in case the homeowner pays. This slide shows another marginal abatement cost curve from Kasicki and Akins. The left figure is again based on individual measures, whereas the right is based on model-based estimates. Model-based estimates often come with higher cost, in part because they usually do not recreate the energy efficiency gap. Kasicki and Akins warn that policy should not lean on these type of marginal abatement curves too strong either. That is, the curves do not give insight into other external costs that are often associated with carbon emissions. It is limited to the measures studied, and there's a tendency to focus on technical savings and to ignore more difficult to estimate measures such as deforestation. Moreover, the cost estimates are only snapshots that do not include differential scope for learning.